So some functions of log normal distribution from Python. That is the objective of this demonstration. So the mathematical form of log normal distribution is similar to the normal distribution. So in order to demonstrate that, I have imported numpy, np, and scipy statistics functions and matplotlib as plt. Right. So let's run it. Okay. So libraries have been imported. In the next step, to represent the equivalence, okay. So at first, I have defined n number of values, n equal to 1000. Then I have generated the random samples from scipy functions of log normal distribution, right? So it requires a shape parameter. So it is greater than 0. So generally, for ideal one, we take it 1. So 0 is the mean value of the underlying normal distribution, right? And 1 is the standard deviation of underlying normal distribution. We said that for log normal distribution, log of x variable is normally distributed. So this is a log normal distribution, right? So if we see that one, so let's define n bins equal to 40, or let's reduce that one, say 25, to make it a fresh calculation. And that is the function to develop the frequency distribution of these numbers, these 10,000 numbers. Okay. So with this one, see the structure of the function fs for frequency, s bins, these are the class limits, and patch, that is required a variable for the function. So s, it is the variable s, the all values, and in n bins with color magenta, right? So we have got this distribution, right? Now let's define, my claim was that this, if I take the log of x, right? So let's define a new variable. I call it log normal s, right? Let me say log of s, right? So log of s, I will say numpy natural log of s variable, right? And let's put it into a distribution. So I say f, okay, frequency of this log of s, then the limits, we'll say log s bins, right? And the word patch equal to plt hist log s variable in some bins, right? So for example, 30 bins, with the color, say blue. And I will say plt show. My claim is that this will be a normal distribution. We have got an error. Okay. I think it is to write the total name. That's it, right? So with the plt plot function and with plt hist function, there is a slight difference in defining the color. So the underlying distribution would appear like this, and it seems to be symmetric about 0. So if you're not convinced, I can say numpy mean of log of s variable, right? And I would say numpy standard deviation of log of s. So the underlying normal distribution has the parameters 0 and 1, right? Mean value and the standard deviation equal to 1. So a log normal distribution is characterized by an underlying normal distribution, right? So the next thing that it is up to you to do the fitting of the distribution. You have the bin values, right? So you can compare it with the theoretical distribution. You have theoretical distribution functions from SPS, scipy, CDF function, PDF function. So you know how to compute that one. And that part is available in this cell, right? So sigma, mu, the mid values of the intervals have been defined here, right? These are the mid values defined. Then the mid values have been computed. They were initialized as 0. And for every class, the mid values have been computed as the average of lower limit and the upper limit, right? And then the theoretical frequencies have been initialized to 0. So we have to have the theoretical frequencies for the number of bins, right? So this is computed from, see here that they are computed from normal distribution. So normal distribution, CDF, class upper limit minus class lower limit probability times n. When you have the probability for one class, right, then you can multiply it with n to get the real values. So you have the rest of the demonstration and see the plotting, right? So plot has been generated for a log normal distribution, and the theoretical distribution is computed from its equivalent or its transformed normal distribution, right? So the log normal distribution calculations can be performed with the help of a general normal distribution. Therefore, the statistical tables for normal distributions can be utilized to evaluate probabilities for log normal distribution. So the rest of the thing has the similar calculation. See here in this cell, the computation of theoretical frequencies has been done with the help of functions available for log normal distribution, right? So you have now two routes on computers, that whether to use the functions of normal distribution or to use the functions of log normal distribution. So it means if you know the log normal distribution, then log normal distribution is a mathematical transformation for it, right? Similarly, for other distributions in the reliability, you may see whether you have the function available or not, and you can move forward on exactly similar lines.